Welcome to day 35. Have you ever built a machine learning model that worked beautifully, only to watch its performance slowly die in production? It's a common and kind of frustrating experience. A model that was once state of the art can become practically useless over time. So that brings us to the core question. Why do great models go bad? It's not usually a bug in the code. The problem is that the world outside the model doesn't stand still. And by the end of this, you'll understand exactly how automated systems are designed to solve this problem, keeping our models fresh and reliable day in and day out. Okay, so this issue of models aging poorly, well, it has a name, and understanding it is really the first step to fixing it. It's called model staleness. Simply put, the model gets old because the world it was trained on no longer exists. The patterns in the data have changed. Think about a model that predicts fashion trends. If you trained it on data from last year, how well do you think it's going to do with this year's styles? Not so well, right? This isn't really a failure of the model itself, it's a mismatch with the new reality. This reality forces a pretty big shift in how we think. Our goal isn't to build one perfect static model. The real goal is to build a system, a machine that can automatically build, test, and deploy new models over and over again. Probably the best way to get an intuition for this is to think of a factory's assembly line. We're essentially building an assembly line for our AI. Just like in a factory, you start with raw materials. For us, that's new data. That's step 1, data ingestion. Then the assembly process begins. That's step 2, model training. But before you ship anything, you have to do quality control, right? That's step 3, model validation. And finally, if it passes inspection, you ship the product to the customer. For us, that's step 4, deploying the model into production. The key is that this entire assembly line runs automatically and continuously. All right, so let's move past the analogy and look at the actual components that make up one of these automated systems. A modern system usually has 4 key parts that work together. First, the data pipeline grabs all the raw data and gets it cleaned up and ready for training. Then, that fresh data is fed into the training pipeline, which builds a new challenger model. Next, and this is super important, the validation pipeline puts that new model to the test. It compares it against the current champion model running in production. Only if the challenger is better does it get promoted. And finally, the serving pipeline is what actually delivers the model's predictions to your users. Now, that serving part can happen in 2 main ways. You've got online predictions, which are generated in real time right when a user needs them. Think of a rideshare app giving you an ETA. Then you have offline predictions. These are calculated ahead of time, usually in a big batch, and then stored so they can be looked up quickly. For example, a system that predicts which customers might churn tomorrow. And here's the most important part. This whole cycle of data, training, and validation isn't a one-time event. It runs over and over, maybe every day or even every hour. This constant loop ensures that the model in production is always the best one, trained on the freshest possible data. So where do these pipelines actually show up? Honestly, once you know what to look for, you'll see them everywhere. Take your email's spam filter. Spammers are always creating new tricks, so the model has to retrain constantly to catch them. Or clothing recommendation engines. They have to keep up with trends that change weekly. Fraud detection is an even better example. A bank can't wait months to adapt to a new fraud scheme. It has to adapt in hours. In all of these cases, model staleness is a huge problem, and pipelines are the only real solution. So why should you, as a practitioner, care? Well, pipelines give you 3 superpowers: automation, which saves you from repetitive manual work; reproducibility, which lets you track exactly how every model was built; and scalability, so your system doesn't break as your data grows. These 3 pillars are really the foundation of what we call MLOps. So if you're going to remember just one thing, let it be this: ML pipelines automate the end-to-end workflow of building and deploying models to systematically combat model staleness. Which brings us to our key takeaway. Stop thinking about building models. Start thinking about building model factories. And as you think about your own work, ask yourself, what's the one piece of my workflow that I do over and over again? That's probably the perfect place to start building your first assembly line.